Okay, so we just sketched an argument that a plus b and a minus b are not going to be divisible by any primes that were part of our original set. Okay, so what does that mean about a plus b and a minus b?
That means that either a plus b or a minus b is prime, or it's 1.
Okay, why do you think that?
Because 1 is not divisible by any of the primes.
Okay.
In the set.
And a prime is not divisible by any of the primes in the set.
Okay.
But there are other numbers that are not divisible by 2, 3, 5, or 7, but are still non-prime.
Okay, give me an example of one.
Like 11 times 13.
Aha! Very good observation. High five. Could a plus b, by the arguments that we've shown so far, can we rule out 11 times 13?
Well, don't think so.
Okay. So we've proved that we're going to get a number that's not divisible by 2, 3, 5, or 7.
But there are still non-primes that aren't divisible by
But that doesn't necessarily mean it's going to be a prime. It means we're going to see numbers that are divisible by new primes, different from 2, 3, 5, and 7.
But what if you had a set that included all the primes?
But there are infinitely many primes.
Very.
You can't include all the primes.
Very well. Interesting. Okay. I was going to go one direction. You guys have chosen to take it in a different direction, which is great. What if we didn't know there were infinitely many primes, and we just thought there were primes up to some number n? Like we stopped at 7, but you, let's say not you guys, but let's say I claimed that some number was the last prime.
Well.
And we did our argument here. So we stopped at n, whatever n was, the last prime. And you guys came and said, well, I'm going to split them into 2 sets, all those numbers. One's going to contain a bunch of these number, a bunch of primes. The other set's going to take the rest of the primes. We'll do the product of the 2 sets. Whichever one's larger we'll call A, the smaller one we'll call B. We'll look at A plus B and A minus B. What can you tell me about A plus B and A minus B?
Well, A plus B is going to be bigger than it's going to be bigger than the last prime.
Right, very good observation. It's going to be bigger. Can you tell me why it's going to be bigger than my last prime I have in the set?
Because you're multiplying that prime by at least one more prime.
Yeah, or even if I took it all by itself, even when I took the last prime all by itself, I'd be adding some number to it. So I get a bigger number. Very good. And what do we know about that bigger number?
And we know that bigger number is prime. We know that it's not divisible by any of our previous primes.
Aha, it's not divisible by any of our previous primes. So what does that mean?
That means we have to, if we find a number, it can either be 1 or prime, but if we find a number that's not, then we have to create new primes.
Ah, okay. So super close. We know it's not 1 because it's bigger than our last prime.
Yeah.
So it's a new number and it's bigger than what we thought was the largest prime.
And it's not divisible by any of the previous primes.
It's not divisible by any of the previous primes.
So
does that mean it's prime?
Well,
no, because it could be divisible by. Well, actually, I think it does because we didn't say that there were any primes beyond a certain number.
Oh, interesting. Okay.
Well, but if there were, so I don't think it means that because it could be divisible by like really big primes.
Right, it could be divisible by more than one prime. It doesn't necessarily have to be prime.
Yeah.
But it is, no matter what it is, it's going to be divisible by one prime or maybe a couple of primes. And what do we know about those primes?
They're not any of our current primes.
They're not any of our current primes.
So that means there are more primes.
That means our list of
Fine.
primes was incomplete.
So
We have to have more.
We have to add more.
You just keep repeating that, so there's infinitely many primes.
There you go. Hey. This is a new proof that there are infinitely many primes.
Oh, cool.
New to me, new to you guys. That's pretty neat. Hey, you guys actually figured out the structure of the proof in a great way.
Cool.
So once again, there are infinitely many primes. Do you remember who the first proof you guys saw that there were infinitely many primes, who that was attributed to?
I remember the proof, but I don't remember the guy.
Isn't it Euler?
Not Euler, but Euclid.
Huh.
So even the ancient Greeks seem to know there are infinitely many primes.
Cool.
And Euclid seemed to know stuff about more than just geometry.
Yeah.
Anyway, this is neat.
Yeah.
Good work this morning, guys. Good work.